Hello, everyone. Thank you for joining us today. We are Eighth Light, and today we're going to talk about AI questions we get asked most often. And today the topic is scalability. And we're going to have perspectives from product, design, and development. But before we dive in, just a quick message about Eighth Light. If you're not familiar with what we are, who we are, we were founded in 2006. We are a software development company. And we have cross-functional partners who help clients imagine and create elegant, robust, and groundbreaking software solutions to complex problems. We've worked with a number of clients across a variety of industries, both large and most recently, we've also worked with a number of startups to help get their ideas off the ground and launch new products. Our approach leverages interdisciplinary teams so that we can build high quality software that meet your needs, design experiences which engage, inform, and enable users to adopt products. And we also work on organizational change through inspiration, through mentorship, and support. And we achieve digital transformation by executing their objectives through technology, product design, and delivery experiences. And I'll start off by introducing you to our experts that are going to be giving this 30-minute talk today. Start off with Pia.
Thanks, Jeff. Pia Opulencia, Head of Product and AI here at Eighth Light. I've got a few decades of experience building and scaling AI products and consumer products, mostly with venture, midsize, and scale-ups across industries, whether that be IoT or healthcare or legal. Most recently, I've also taught the inaugural Technical Product Management course at Northwestern University's MBA in AI program, and a few patents on AI technology.
Thank you, Pia. My name is Josh Milewski. I'm the design director here at Eighth Light, and I've been working in UX and design for about 2 decades. I've worked at large and small companies like Food Network, Google, Citibank, and I'm really passionate about technology and figuring out how to evolve technology to meet real world challenges. And now I'll turn it over to Josh to introduce himself.
Thanks. Yeah, Josh Milewski, principal crafter here at Eighth Light. I really like just taking on technical challenges, discussing, organizations challenges, and kind of learning about different industries. I've been working now in AI specifically for a couple of years across multiple different fields, including constraint programming and generative AI. So, yeah, just happy to talk a bit about scalability in Gen AI here today.
Thank you, Josh. If you have any questions or comments during our chat, feel free to use the chat functionality to let us know what thought you have or what question you have, and we will try to respond to it as quickly as we can. And with that, we will dive right into product, and I'll turn it over to Pia.
Great. So with respect to scalability, we might ask ourselves as product practitioners what we should be keeping in mind when we are trying to scale our AI-powered products. And I think reiterating the multiple areas of product consideration is one place to start. So the notion here, validated and done some user testing on a prototype of your AI-powered product. Minimally, you already took a look at the costs of your foundational models and your query costs. You've gotten some validation on your UX, solving the actual customer use case. Hopefully, you've done a good job proactively implementing some data privacy and security practices on your prototype. But as you can see here, there are many other aspects of product development and requirements to consider before you can launch into a full-fledged production application. And so it just gets more complicated, right? The needs for versioning, the needs for scaling, your infrastructure get more important when you're trying to grow your user base, and maybe not even grow your user base, but you're increasing your usage in your application. Think about the multiple vectors by which we're talking about scale throughout this conversation. Similarly, with monitoring and maintenance, you probably did some light model evaluation and training to get your prototype validated, but it's even more important to set alerts and make sure that model drift, a concept that we talked about yesterday in our other section, gets addressed during this stage of development. And so a couple key emerging needs that make it different from those normal, pretty traditional product topical areas to consider is vendor selection. I think this is a pretty apt quote from Stanford's 2024 AI Index report, which they'll be refreshing for next year, of course. But 149 foundation models were released in 2023, which was already double from 2022. And so if we think about how fast we're going to have to do version control, library maintenance, making sure that the prototype foundational model that you use didn't go out of business and actually solves your use case is something to plan for as this market and ecosystem continues to change pretty rapidly. And so, some of the tried and true practices of don't put all your eggs in one tech basket, right? Or make sure that you're having cross-functional views on selecting your vendors and your technologies is very important for Gen AI products. I'll lightly touch on this. I think our friend Josh here is going to dive into it a little bit more, but emphasis on reusability. And not just, I think traditionally we think about reusability in design systems, component design, but now we can think about reusability as well in data pipelines, model components, reused parameters across different algorithms that you're developing. And really it's for the same outcome of reducing redundancies and maximizing applicability as you build your AI models to solve multiple customer use cases. Another one is the notion of a feature store. So again, with that versioning and traceability across ML models and parameters, you want to make sure you're maintaining data quality throughout your process as you're scaling your system. And then we'd be remiss not to emphasize the increasing importance of governance as you scale your system, making sure that you're involving finance, legal, and customer success as you work to do cost optimizations on your models, look at total cost of ownership of your models, as well as whether or not you need to sunset, per my vendor selection comment earlier. And so net, I think a really good adage is to prioritize product foundations that support rapid experimentation in this changing market. More importantly, having a fallback on delivering value. I think OpenAI, ChatGPT had an outage last night, right? So I think it's pretty timely to think about your user experience, think about how when your system scales, you want to make sure that your users are still achieving the outcome that they're coming to your company for. And so that might be other fallback systems that are not reliant upon highly uptime kind of Gen AI systems. And with that, I will turn it over to Jeff for a design perspective.
Thank you, Pia. So one of the questions people talk to us a lot about is how will the design evolve as the AI system scales while maintaining consistency? And just to touch on something that Pia just mentioned, when we say AI system scaling, it could mean your user base is growing. It could also mean that you're using a new AI system, right? That maybe is more robust and has some different features. One of the things that you've heard before we even started talking about AI, but now is even more relevant, are design systems. You always want a modular and scalable design system that has consistent patterns for certain interaction models and simple to usability rules on how people would interact with those modules. These modules should be dynamic so they can easily adapt as new features are being added, and they should all follow the same level of principles and have the same visual aesthetic. And one of the things that is becoming even more pronounced now, like it did when the internet actually started, are chatbots. And chatbots can dramatically simplify complex interaction models. Of course, you have to make sure the user knows how to talk to a chatbot, but if you have a robust library of communication patterns, it can be a little easier. One of the best examples of a component library that's reusable, scalable, responsive, so work on mobile and desktop, is Airbnb. They use what they call atomic components that start out with the smallest module, which could be like a form field, and slowly starting from that point, build it out into a larger form. And this is very scalable, very easy for developers to work with, very easy to quickly create new versions of a page and then evolve the design as needs change and as systems grow. Wells Fargo is doing something called Fargo, and this is a chatbot that you can talk to instead of potentially navigating the app. So instead of going to your accounts page or your transfer page, you can say, Fargo, I want to transfer $500 to this account, and then it will automatically take you to that page. This is a really interesting way to navigate. And when you look at some of the numbers that they published, you can see that 65% of millennials and Gen Z respondents prefer to use a virtual assistant for customer service needs versus actually talking to somebody. They actually trust a chatbot over human interaction, which was an astounding number to see. I do totally believe it now because these things have gotten much more robust and much smarter. And time is so critical. And when you can just tell a chatbot, go to this section of the app or do this instead of having to find it in a menu or type something into search and hope that you get the right query, just speaking it and having it respond to you immediately is hugely, hugely valuable for users. But again, it's a transition, right? And they're using this as well as still have the traditional navigation. So they have both in place. So this is an interesting way to kind of introduce a chatbot that helps you navigate the product in parallel to your existing nav. And at some point in time, maybe your product is 100% chat. Adaptive UI is a really exciting concept. We're talking about interfaces that automatically adjust its layout, content, and potentially functionality to meet the needs of the user, contextually where they are, what they need at this moment in time, or what they've done in the past, or what they've customized. And these UIs are slowly starting to emerge. One of the ones that you may be familiar with is Netflix. It's a highly scalable and adaptable design system that personalizes what you see based on the viewing habits of the user. Now, you may not be surprised that you'll see content that you may like here, but the categories, top picks, sci-fi, are arranged in a specific order based on your viewing habits and what they think you will click on. But if you go one level deeper, they even have personalized artwork selection. So for something like Stranger Things, maybe they notice that you're more a kind of a darker person and you might actually click on something that looks a little more ominous, or maybe you want a little something bigger and more bright, or maybe you really want to be up close with the characters and you're driven by faces, seeing close-ups of faces, then they're going to use this. So it's the same piece of content but different artwork to represent that content based on your viewing habits, again, to optimize experience, to get more clicks. So it's actually an adaptive, it's a framework for an adaptive design system that optimizes the content. The other thing that's really critical as you start scaling these systems are feedback mechanisms. So you need to understand what is working and what is not working with your AI product. It's impossible to understand all the scenarios that Gen AI could potentially give. So you need help doing some QA. And here's where feedback mechanisms, which are always valuable from a UX standpoint, are even more valuable when you're talking about evaluating AI products. And you've probably seen a lot of these, but Google with Gemini and OpenAI have contextual control that you will often see. Is this the result you wanted? Yes or no? Thumbs up or thumbs down. Very simple, very straightforward. Maybe there's a copyright issue, report legal issue. Let us know about it. Right? Sometimes you'll also see two responses. Which response is better, the first one or the second one? And then with that data, the model can dynamically update its engine and be better the next time it presents a result. And you can also look at error rates over time to see if your system is becoming more or less accurate. With that, I'll turn it over to Josh to talk a little bit about the development side.
Thank you. Just going to get my notes up here for a moment. Right, so development. What technical architecture is needed to ensure scalable AI? So I'm going to focus here on the fundamentals, sort of practical first steps of prototype to production. Starting off, you might just throw everything at the LLM, right? Taking advantage of GPT's guardrails and prompt engineering, but this can really only get you so far. And with a monolithic model like this, while we can perform end-to-end evaluations for safety, alignment, and quality, a change in favor of one might regress another, and we don't really have a way to find out why. So instead, modularity helps solve this. Sort of the ability to identify specific tasks and extract them into services that may not necessarily be generative AI, but which can produce clean data to feed into your LLM. For example, we might implement a prompt classifier. So using tried and true natural language processing techniques, again, not generative AI, we can create a service that classifies a user's prompt into one of several predefined categories. And with well-defined outputs, we can evaluate performance of different implementations. We can also test that the classifier has the output we want. We have a much greater degree of direct control following this method, and this gives us the ability to have a traditional separation of concerns. We could then integrate that classifier in between the user prompt and additional custom logic. For example, say we have a health coach app. The user asks a question. In this case, they want to start exercising, but they don't have a gym membership or any equipment. Our classifier could classify that prompt and give it the label exercise beginner. We could then add additional custom logic to determine what to do with that prompt. Essentially, should we allow it to be provided to the LLM? And finally, these structured data can then be provided as additional inputs along with the original prompt to enrich the performance of the language model. You can imagine you might start feeding in additional content too. For example, you might look at the user's profile and find a gym near them that you want to provide. But the key point is that since this all happens downstream of the classification, we have more control over the inputs to the LLM. And this modularity is what's key to your initial scalability. Each component can be well tested, isolated, and evaluated. Speaking of evaluations, what does that look like in terms of unit tests? If you're testing LLMs, first of all, you might want to use LLMs themselves to generate lots of test cases that you can embed into your test suite and add assertions to ensure that the LLM consistently produces the result you expect. And you can use that data in turn to fine-tune your models. It's important to note here that unlike in traditional software engineering, we might not be aiming for 100% green test coverage. When it comes to the health app example that I provided, that might actually be the right goal. But in general, this is a product decision for how many LLM failures are we willing to tolerate. Human evaluation is also essential to training and potentially a barrier to scaling. But we do recommend that you start simple. Is the output from the LLM good or is it bad? Before moving on to more advanced evaluation techniques. Over time, as your metrics improve, you can also move to sampling output rather than evaluating every single one. Of course, there are vendor dependencies, right? If you're building fully around OpenAI, you might sort of be locked into their pricing and services. But if you do build with modularity and evaluations in mind, it becomes easier to swap out and race different models against each other and kind of keep your options open. For a little more detail, model training is far more computationally intensive than model inference. Inference is what happens when you prompt a trained model and get an output. It's, when you go to chatgpt.com, right, and put in a prompt and get an output, that's inference. But inference itself can actually still be quite computationally intensive. You can actually kind of test this out yourself. If you download Ollama on your own laptop, for example, and try running a large model, you'll find, and give it a prompt, you'll find that it could be several orders of magnitude slower than a response from ChatGPT, which kind of points to the difference in scale for computation here. So really, we do recommend starting with general purpose off-the-shelf services with that in mind. to build up your tooling and experience. You'll benefit a lot from leveraging the resources of a company like OpenAI or Google. This isn't too dissimilar from cloud computing in general. But, with that in mind, we also recommend that you build with that modularity as well, so that over time you can scale. Right. So one more thing I want to talk about here is ML ops. This is a broad range of techniques borrowing from DevOps. Essentially, it's treating data sets and models as first class. It's kind of an expansion of DevOps to include data science and domain expertise. What I want to talk about here is that, this is a very big topic, but the thing I want to focus in terms of scalability is that um, a big barrier to ML ops that we see is often actually organizational. It requires collaboration between data science and operations and a culture of continuous improvement. And this often requires significant changes in organizational culture and priorities. But it is, a key thing to keep in mind is that successful scalability with ML ops, it's not an overnight or individual process, but it requires organizational commitment. And along the same lines of ML ops is, what are we actually trying to evaluate for there? One thing that we mentioned, Pia mentioned just a bit before, was model drift, or better stated, distributed shift in the environment. So what I mean by that is you might deploy a service with a fine-tuned model and you're meeting all your performance metrics the first week. Then the next week you see them drop by 5%, and then you see that again a week after that. What might be happening here is the product was a good fit for your market and users when launched, but as users begin to interact with it differently, your model might no longer be the best fit for the environment. So it's important to continuously monitor this and feed that data back into your fine tuning. And I also want to touch briefly on alignment and safety. We always need to consider GDPR and so on in any project. But with LLMs, there are additional risks which are starting to be embedded in laws like the EU AI Act. It's not really the focus right now, but it is crucial to keep an eye on risk and safety, especially as you scale to more users and higher risk systems. So just as a summary of everything I just kind of talked about is, start small, off the shelf, modular, continuously evaluate performance, alignment, and safety, gather data and fine tune over time, and prepare for organizational change. This really requires collaboration and commitment from all levels of an organization. And with that, I'm going to pass it back over to Jeff to see if
Thank
we
you,
have any.
Josh. Thank you, everyone, for attending. Are there any questions or comments that anyone has? Feel free to use the chat. Okay. Well, if there's nothing, no comments or questions, just want to again thank you all for joining. We appreciate you listening in. And if you do have any questions or comments in the future, feel free to reach out. Thank you so much, Josh and Pia, for your help today. And we will talk to you all soon. Be well. Take care.
Thanks.
Thank you.